Welcome students. I am Anuradha Sharma, your maths teacher. Today's topic is inverse trigonometric functions, class 12th maths. In this session, we will study about the what is function, what is inverse of a function, what is trigonometric function, and what is inverse trigonometric functions. So let's start. What is function? If A and B are two non-empty sets, you know very well the meaning of the sets. Sets is a well-defined collection of objects. If A and B are two non-empty sets, then f is said to be a function from A to B if it is defined only if when set A is entirely used up. By example, we can easily understand that if we take 2, 3, 4 are the members of set A and 4, 9, 16, 25. These are the members of set B. So 2 is associated with the 4, 3 is associated with the 9 and 4 is associated with the 16. So we can say nothing is left in the set A. So set A is entirely used up. So we can say it is represented as a function. Now look at the second point. In set B, may or may not be entirely used up. So we can easily understand by the same example. If set A contains 2, 3, 4, set B contains 4, 9, 16, 25. 2 is associated with the 4, 3 is associated with the 9 and 4 is associated with the 16. So we can easily locate then the 25, it does not have the pre-image in the set A. So that's why we can say set B is not entirely used up by the element of the set A. Look at the third point. In the third point, an element of domain A cannot associate with more than one element of the set B. Look this example. Set A contains X and Y, these two elements. Set B contains A, B and C, these three elements. X is as related with the A and the X is also related with the B. So it means we can say then X is associated with the two elements of the set B. So it does not represent as a function because it is already mentioned in the third point. An element of domain A cannot associate with more than one element of the set B. Look at 4 point. In the 4 point, more than one elements of domain A may associate with the same element of codomain B. Look this example. In this example, X, Y, Z, these are the members of set A and A, B, C, these are the members of set B. X is associated with the A and Y is also associated with the set A and Z is associated with C. So we can easily look at X and Y. Both are showing same image A. So that's why it verified the fourth point. More than one elements of domain A may associate with the same element of codomain B. So we can say this represent as a function. If all the four conditions are satisfied by the sets, so that's why we can say it represents a function. So these conditions must be satisfied for a function. Again, I am repeating the definition of the function. A function f from A to B is defined only if set A is entirely used up. Set B may or may not be entirely used up. An element of domain A cannot associate with more than one element of set B. Fourth point, more than one elements of domain A may associate with the same element of codomain B. That is the definition of the function. Now, we can say f is a function from A to B if A represent as a domain and the set B represent as a codomain. Set of all the images of elements of set A under the F is called the range. Look this example. Set A contains x and y, these two elements. Set B contains A, B, C, these three elements. X is associated with the B, Y is associated with the C. So we can say domain is represent the X and Y, these two elements, because these two elements are lies in the set A, and codomain is represented by the A, B, C, because these three elements A, B, C are lies in the set B. Look at the range. So range is represented by the B and C, because B has the pre-image in the set A and C has the pre-image in the set A. So that's why B and C are the members of the range. Now we know very well domain is represented as the set A, codomain is represented as the set B, and set of all the images of elements of set A under F is called the range. Look at this. If we imagine a machine named as F, the machine takes some input and depending upon its mechanism, it gives output. So let the mechanism set inside it 2x plus 3. So if we insert a number x is equal to the 1 into the machine, then its mechanism gives 5 as the output. If we insert the number x is 2, then its mechanism gives 7 as a output. So if x is 1, so we can say if the function fx is 2x plus 3, its mechanism is already set 2x plus 3, so we get the output is the 5. Similarly, if we insert the x is 2, then its mechanism gives 7 as a output. So it means 2 multiplied with the 2 plus 3, we get the 7. So output is because the 7. If we think in the reverse order, so if we say, then what should be the input if the output is the 5? So it means the function fx is given as a 5. So its mechanism is already decided as a 2x plus 3. So we can say this is equal to the output. Output is the 5. So now we can easily get the input. So its input is equal to the 1. If the mechanism is decided, then 2x plus 3. So then we can easily get the input value. If output is the 5, so input is the 1. And if output is the 7, so input is the 2. So now we can say if the output is the y, so its mechanism has 2x plus 3. So that's why we can say the 2x plus 3 is equal to the y. Now we can easily find the value of the x. What should be the input? Input is the y minus 3 upon 2, because output is already the y. So we can say the x is equal to the y minus 3 upon 2. So we can easily get the input by the y minus 3 upon 2. So that is the reverse process. So inverse of the function is equal to the x minus 3 upon 2. So we can say if f is a function from a to b, when fx is equal to the 2x plus 3. But in reverse order we can write the inverse of a function from b to a if f inverse of the x is equal to the x minus 3 upon 2. That is known as the inverse function. So, invertible function, if f is said to be an invertible function, if its inverse exists. So, two conditions must be satisfied. First one is the 1, 1. Second one is the onto. If the any function is a 1, 1 and onto, so we can say its inverse is exist, otherwise its inverse will not be exist. So what should be the 1 1? Then it means then each element of the set A has unique and distinct image in the set B. In this example, we can easily look at X is associated with the A, Y is associated with the B, and Z is associated with the C. So that's why all the element has the distinct image in the set B. So that's why it is represented as a 1-1 function. For the onto, the set B entirely used up. That's why it is known as the onto function. So if we look the same example, we can easily locate the set B contains A, B, C, these three elements. So A has the pre-image in set A, and B also has the pre-image in the set A, and C also has the pre-image in the set A. So the set B is entirely used up by the element of the set A. So that's why it is represented as a onto function. So now we know very well the what is the 1 1 and what should be the onto function. If any function is a 1 1 and onto function, so if these two conditions are satisfied, so we can say its inverse is exist. Otherwise, its inverse will not be exist. Graphical test of for the function. So we can also test graphically. By the graphically, we can easily understand whether the function whether it is represented as a function or not. So if we draw a straight line which is parallel to the y-axis and does not cut the curve at more than one point, then that curve represents a function. Otherwise, it will not be a function. This is also known as the vertical line test. If y is equal to the fx and we draw the graph for the given function, so substitute the values of the x to get the value of the y and draw these points on a graph paper, so we can easily get the curve for the given function and draw the line which is parallel to the y-axis. It intersects the curve at a single point, so it means the curve represents a function. If we take the another type of the function and draw the graph for this function, so we get this type of the curve and then draw the line which is parallel to the y-axis. It intersects the curve more than the one point. So that's why we can say curve does not represent a function. Now graphical test for the 1-1 function. So if we draw a straight line which is parallel to the x-axis, does not cut the curve at more than one point, then that curve represents a 1-1 function. This is also known as the horizontal line test. So look this example. If we draw the graph for the any other type of the function and then draw the line which is parallel to the x-axis, it intersects the curve more than one point. So the function is not a 1-1 function. If we take the another type of the graph and then it is it, it is look like this. So we can say if we draw the line which is parallel to the x-axis, it intersects the curve at a one point. So that's why this is represented as a 1-1 function. Trigonometric function, you know very well, sin x, cos x, tan x, cot x, sec x, and cosec x. These are known as trigonometric function. if we take y is equal to the sin x, substitute the different values of the x to get the value of y. So if we substitute the x is 0 degree, so we get y is equal to the 0. And then if sin pi is 0, then we get the value of the y is 0. Sin 2 pi is also 0. Therefore, y is 0. And x is the 0 pi, 2 pi, 3 pi and 4 pi and so on. Then we get value of the y is the 0. And similarly, if we take the x is pi by 2, so sin pi by 2 is the 1. Sin minus pi by 2 is also 1. Sin 3 pi by 2 is the 1. Sin minus 3 pi by 2 is also 1. Sin 5 pi by 2 is the 1. And sin 7 pi by 2 is also 1. And so on. So we can easily locate at the different value of the x pi by 2, 3 pi by 2, 5 pi by 2. Then we get the value of the y is the 1. Now, if we draw these points on a graph paper and then join together, so we can easily get the graph for the sin x function. So graph is look like this. It is a periodic graph because after a fixed interval, then sin x value is repeated. So that's why we can say it is known as the periodic graph. For the inverse to exit, function must be 1, 1 and onto, and it does not represent the 1, 1 function because sin 0 is the 0, sin minus pi is the 0, and sin minus 2 pi is also 0, sin pi is the 0, sin 2 pi is 0. So at the different value of the x, it shows the value of the y is the 0. So that's why sin x is not 1, 1 function. Otherwise, we can also check by graphically. If we draw the line which is parallel to the x-axis, it intersects the curve more than the 1 point. So that's why we can say then sin x is not 1, 1 function. And similarly, we can also say it is not a onto function because if we take the 2, 4, 5, 6, so we can easily locate it does not represent the any value of the x because then this graph only lies in between the minus 1 to 1. So we can say let fx is equal to the sin x, it is equal to the y, and y is equal to the 2. This is belongs to the real number, but there is no x belongs to the r. So that's why sin x is not onto function. Now we know very well, then sin x is neither 1, 1 nor onto function over their natural domain and range. Natural domain and range mean it is from R to R. So we can say then f is for a function from R to R is defined by fx is equal to the sin x. Function is neither 1, 1 nor onto function. So, but the range of the function is specified, so it becomes the onto function. So if we specify the range of the sin x function, then we can say then sin x is becomes as the onto function. So if we restrict the range in close interval minus 1 to 1, so the sin x function becomes the onto function. We can write f is a function from R to close interval minus 1, 1 is onto function. Now, we can easily locate in this graph, then if we restrict its domain from minus 3 pi by 2 to minus pi by 2. So we can easily locate, then it shows the 1, 1 function. So if we restrict this, look this star minus 3 pi by 2 to minus pi by 2. So if we draw a line in this portion of the curve, so we will get, we can easily locate this line which is parallel to the x-axis intersect the curve at a one point. So therefore, if the domain is restricted between the closed interval minus 3 pi by 2 minus pi by 2, then sin x becomes the 1 function, and range is also restricted. So that's why we can say f is 1 and onto function. If you restrict its domain from minus pi by 2 to pi by 2, so again we can draw the line which is parallel to the x-axis. It intersects the curve in this portion at a single point. So that's why we can say then the sin x becomes the 1 function under this domain from minus pi by 2 to pi by 2. So we can say if the domain is restricted from minus pi by 2 to pi by 2 and range is already restricted from minus 1 to 1, so that's why function is 1 and onto function. Now if we take the domain from pi by 2 to 3 pi by 2, so we can easily locate then again in this portion of the curve, then it is the 1 function. So we can say under this domain from pi by 2 and 3 pi by 2, then function is 1 and range is already restricted, so that's why it is onto function. So now we can easily locate then if m becomes the 1, we restrict its domain to interval D, and it is denoted by the D. So D may be any one of the interval, close interval minus 3 pi by 2, minus pi by 2, close interval minus pi by 2 and pi by 2, and pi by 2, 3 pi by 2, and so on. So if we restrict its domain, then the sin x function becomes the 1 function, and range is already restricted in closed interval minus 1 to 1. So that's why f is 1 and onto function. If the any function is 1 and onto function, so it is known as the bisective function. And if the if function is 1 and onto, so we can say its inverse is exist. So for inverse to exist, function must be 1 and onto. So we can write f inverse from close interval minus 1 to D. So it means in this we have to reverse the order to writing the inverse of the function. Now you know very well the D has the D shows many intervals. If we choose the least value of the D, it means if we choose the close interval minus pi by 2 pi by 2, that is shows the least value of the D. So we can say then f is a 1 and onto function from close interval minus pi by 2 pi by 2 to minus 1 and 1. So function is 1 and onto function. If function is 1 and onto, so its inverse exists. So we can write in the reverse order f inverse from close interval minus 1 to close interval minus pi by 2 pi by 2. So f inverse is because the sine inverse. So we can write sine inverse from minus 1 to close interval minus pi by 2 pi by 2. So that is known as the inverse of the sine function. The smallest numeric value, either negative or positive value of an inverse trigonometric function is called the principal value of the function. Look at again this diagram. So I have taken the domain from minus pi by 2 to pi by 2. So it means I am talking this portion of the graph, this one. So in this graph, then we can say then domain is restrict from minus pi by 2 pi by 2 and range in it is already restrict minus 1 to 1. So that's why sin x function becomes the 1, 1 and on 2. So we can say x value is lies in between minus pi by 2 to pi by 2. So we can write x is more than or equal to the minus pi by 2 but less than or equal to the pi by 2. Then value of the y is lies in between minus 1 to 1. Now we can write the domain and range of the inverse of sine. So sine inverse x, domain is minus 1, 1 and range is minus pi by 2 to pi by 2 because sine inverse function from close interval minus 1, 1 to minus pi by 2 pi by 2. So we can easily differentiate the y is equal to the sine x and y is equal to the sine inverse x. If it is written y is equal to the sine x, it shows the trigonometric function. It means sine x, it means x shows the angle and y shows the sine value. If we are writing the y is equal to the sine inverse x, so we can say then sine inverse of the x, it means x shows the value of sine and y shows the corresponding angle. So there should not be any confusion in between the trigonometric function and inverse of trigonometric function. Now you know very well then how to get the graph of sine inverse x. Now the domain is the minus 1 to 1. So we have to plot on the x-axis and range we have to plot on the y-axis. It is minus pi by 2 to pi by 2. So we can say it is represent the sine inverse x graph and it is also denoted by sine inverse x also denoted by the arc sine x. Similarly, we can easily draw the graph of others inverse trigonometric function. Now, look at here. All the trigonometric functions repeat their values after fixed interval. So, they are neither 1, 1 nor onto function. But if we restrict their domain and codomain, so they can make 1, 1 and onto function. So that's why it is known as the bisective function. If it 1, 1 and onto function, so we can write its inverse exists and we can obtain their inverse. Now we find the inverse of other trigonometric function. So look at this graph. This is the graph for the cos theta. So then it is also the periodic graph and we can easily locate then after the certain value then its values are repeated. So if you look at this value 0 degree and this is the 180 degree and then if we take the graph, if we take this portion of the graph, so we can say then in a specific domain from 0 to 180 degree, it shows the 1, 1 function. And if we restrict their range from minus 1 to 1, so it shows the onto also. If we restrict its domain from 180 degree to 360. So this portion of the curve, it shows the 1 function, and raise is already restrict from -1 to 1. So that's why it becomes the onto. Similarly here, if we restrict the domain in between 360 degree to 540 degree, so this portion of the curve, it shows the 1 function. So now we have to take the least value of the cos x function. So least value of the cos x function is 0 degree to 180 degree. It means we can write from 0 to pi. So if the domain is from 0 to pi and range is -1 to 1, so that's why cos theta becomes the 1 and onto function. So we can easily draw the inverse of cos, and now we can easily locate the function is equal to the cos inverse x. Then domain becomes the -1 to 1 and range is from 0 to pi. And look at the function tan inverse x, then domain it is belongs to the R and range is from -pi by 2 to pi by 2. Similarly, we can easily locate the others inverse trigonometric function. Look at cot inverse x, then domain is belongs to the R and the range is the between 0 to pi. And if you look at the function cosec inverse x, then it is also denoted by the CSC inverse of x. So we can easily look at there, then it graph does not lies in between -1 to 1. So this interval should be separate from the R. So we can say domain for the cosec inverse x is equal to the R minus open interval -1 1 and range, because the f cosec 0 is the undefined value. So that's why we can say then the range in between -pi by 2 to pi by 2 except the 0 degree. Now look at the fx is equal to the sec inverse x. Then we can easily observe this graph. Graph does not lies in between -1 to 1. So we can write the domain for the sec inverse x is equal to the R minus open interval -1 1, and we know very well the sec pi by 2 is the undefined value. So that's why we can write the range of the inverse trigonometric function sec inverse x. The range of sec inverse x is equal to the 0 to pi except the pi by 2. So now we know the domain and range of the inverse trigonometry function. So all the trigonometry function, they are not 1 and onto function, but if we restrict their domain and range, so they becomes the 1 and onto function. If they becomes 1 and onto function, so its inverse also exists. So that's why we can easily get the inverse trigonometric function with the domain and range. Now sine inverse x domain is close interval -1 1 and range is close interval -pi by 2 pi by 2, and cosec inverse x domain is -1 1 and range is close interval 0 pi, and tan inverse x domain is R. It means from -infinity to infinity, and range is -pi by 2 pi by 2, and domain for the cot inverse x is the R, and range for the cot inverse x is close interval 0 pi. Domain for the sec inverse x is r minus open interval minus 1, 1, and range for the sec inverse x 0 to pi except the pi by 2, and domain for cosec inverse x is r minus open interval minus 1, 1, and range is minus pi by 2 except the 0. So now we can easily say about the domain and range of the inverse trigonometric function by this chart, and we can easily learn the domain and range of the inverse trigonometric function by this chart. So in this we can easily locate, then x is represent the domain value and the y represent the range. So if we take the value minus 1, 0 and 1, so we can easily locate sine pi by 2 is the 1 and sine minus pi by 2 is the minus 1. Sine 0 degree is the 0. So now we can say the domain is minus 1 to 1 and range is minus pi by 2, pi by 2. For the cos inverse x, then cos pi is the minus 1, cos 0 is the 1, and cos pi by 2 is the 0. So domain is minus 1 to 1 and range is close interval 0 to pi. And if we talking about the y is equal to the tan inverse x, so we know very well tan pi by 4 is the 1, tan minus pi by 4 is the minus 1, tan 0 degree is the 0, and tan 90 is the undefined value. Similarly, tan minus 90 is also undefined value. So we can write its domain is lies from minus infinity to infinity. Otherwise we can write it is equal to the r and range is minus pi by 2 to pi by 2. And if the cosec inverse x, then domain, if we have to find the domain and range of cosec inverse x. So if we writing the value of the x minus 1 to 1, and we can say cosec pi by 2 is the 1, cosec minus pi by 2 is the minus 1, but cosec 0 is the undefined value. So we can say then domain must not be lies in the interval minus 1 to 1. So that's why we can write the domain for the cosec inverse x is equal to r minus open interval minus 1 to 1, and range is minus pi by 2 to pi by 2 except the 0 degree. Similarly, we can write the domain and range for the sec inverse x. So sec pi, you know very well, this is equal to the minus 1, and sec 0 degree is the 1, but sec pi by 2 is the undefined value. So it means then the domain is equal to r minus this open interval minus 1, 1, and range is the 0 to pi except the pi by 2. And similarly, we can find the domain for the cot inverse x. This is cot inverse x. So now we can write the cot 0 is the undefined value, cot pi by 4 is the 1, cot pi by 2 is the 0, cot 3 pi by 4 is the minus 1, cot pi is the undefined value. So domain is the r and range is the 0 to pi. So we can easily learn the domain and range. That's it for today. In next video, we would learn properties of inverse trigonometric function. Thank you.